Good morning, everyone. We're on lesson 116, page 490. And this lesson is on quotients, which means the answer to a division problem. Quotients with square roots. So the problem starts out looking like this. And we know that we cannot leave a square root in the denominator. It's not proper form. So the way we get rid of that is we look at the denominator. There's a square root of 3 in it. So if we multiply by square root of 3 over square root of 3, we can get rid of that radical. And the reason we multiply by square root of 3 over square root of 3 is because this just has a value of 1. And we can multiply by any form of 1 that we need to. So here, square root of 5 times square root of 3 is square root of 15. And down here, square root of 3 times square root of 3 is 3. So that's it. Okay, the next one is 4 plus the square root of 3 over the square root of 2. So the only thing that's wrong with this is that square root of 2. So we have to get rid of it. So we multiply by square root of 2 over square root of 2. And now I'm going to put this in parentheses because this square root of 2 has to be distributed here and here. So when we multiply 4 times the square root of 2, we get 4 square root of 2 plus, here they're both under the square root, so we simply multiply the numbers. 3 times 2 is 6, and in the denominator, square root of 2 times square root of 2 is 2. All right, are we finished? Yes, we're finished. Unless I can factor a number out of the entire numerator, then I can't reduce anything. And I can't factor anything out of 4 square root of 2 and square root of 6. So it is in simplest form. Don't you dare try to cancel the 2 into the 4. You cannot do that. All right, one more. Okay, so what do we need to multiply by here to get rid of the square root in the denominator? That's right, square root of 5 over square root of 5. So what are we going to get? Remember, this has to be distributed. So square root of 5 times 2 is 2 square root of 5 plus, both of these are under the radical, so we multiply them and leave them under the radical. And then square root of 5 times square root of 5 is 5. Now, what's wrong with this one? The square root of 75 can be simplified. What goes into the square root of 75 that's a perfect square? 25, right? 25 times 3. And what's the square root of 25? So this becomes, the 2 square root of 5 stays the same, but now this is going to become, the square root of 25 comes out, the square root of 3 stays under, and then 5. And again, can we cancel anything? Absolutely not. You cannot cancel the 5s, right? You have to be able to factor it out of the entire numerator in order to be able to cancel it, and we can't do that. So that's the final answer. Okay, guys, that's it for this morning. Thank you.